Now let's discuss here question number 56. It states that let ABC be a triangle whose sides are ABC. Then length of the medians of the triangle formed by the median of the triangle ABC are out of these four options. So let's try to find an answer to this question. If we are talking about a triangle whose sides are A, B and C. So here sides are measuring A, B and C. Then what will be the length of median in this case? If I consider here the length of medians will be according to the sides. That is, median on A will be measuring half of square root of 2b square plus 2c square minus a square. In similar manner, if I consider here median on B, then that will be given by half of square root of 2a square plus 2c square minus b square. Further, the median on C will be of the length half into square root of 2a square plus 2b square minus c square. And in this question, you are being asked about the length of the median of the triangle, which is formed by the medians of this triangle ABC. So, if a triangle is formed by the medians of the triangle ABC, its sides will be given by MA, MB, MC. So, let's consider here that the length of medians of triangle formed by medians of triangle ABC are PQ and R, where in this case P will be equal to half of square root of twice M B square plus twice M C square minus M A square. And when you simplify this, here you are going to get the value equal to 3 upon 4 times A. Therefore, I get the value of P equal to 3 upon 4 times A. Similarly, on the same pattern, you will get the value of Q equal to 3 upon 4 times B, and the value of R will be 3 upon 4 times C. So, taking this into consideration, I can now definitely say that the length of the medians of the triangle formed by the medians of triangle ABC is given by 3 upon 4A, 3 upon 4B and 3 upon 4C. So, out of the four options given to us, now you can definitely identify your answer. The length of the medians of this triangle formed by the medians of triangle ABC is given by option number 3. So, you can definitely mark your answer as option 3. I hope this question is clear to you. Now, let's proceed to our next question. Now, let's discuss question number 57. It states that x plus 1 raised to the power 4 is divided by x minus 1 cube. Then the value of the remainder at x equal to 1 is out of these four options. So, let's try to find an answer to this question. Here we are talking about x plus 1 raised to the power 4. When you expand this, here you will be getting x raised to the power 4 plus I have 4x cube plus 6x square plus 4x plus 1. And when I consider here the divisor x minus 1 cube, this is equal to x cube minus 3x square plus 3x minus 1. So, let's do here the long division to get the required remainder. So, here I am applying here long division methods. This is the divisor x raised to the power 4 plus 4x cube plus 6x square plus 4x plus 1. Let's divide it with x minus 1 cube. So, firstly, I'll take the first term in the quotient, that is the leading term will be here x. X into this expression will give me here x raised to the power 4 minus 3x cube plus 3x square minus x. Let's change the sign here. On changing the sign, this will become minus plus minus then plus. Here this gets completely cancelled, and on simplification here you get 7x cube and here we get plus 3x square plus 5x plus 1. Well, next term in the quotient will be equal to plus 7. So here, on further dividing it, 7 into this term gives me here 7x cube minus 21x square plus 21x minus 7. Now, let's change the sign over here. On changing the sign, minus, plus, minus and plus, here this gets cancelled. Next, as a remainder, you are obtaining 24x square minus 16x plus 8. Here we cannot further divide it because here degree of the remainder becomes less than the degree of divisor. So, you need to obtain the value of remainder at x equal to 1. So, I could write here at x equal to 1, here r of x, that is remainder, is 24x square minus 16x plus 8. That means at x equal to 1, the remainder will be 24 into 1 square 1 minus 16 plus 8, which simplifies to the value 16. So, the answer will be here 16. I hope this question is clear to you. Let's get back to the options provided to us. Out of these 4 options, you can clearly see the remainder of this division at x equal to 1 is found in option number 3, that is 16. So, here I can definitely mark the answer for this question as option 3. I hope it is clear to you. Now, let's proceed to our next question. Here we have question number 58, which states that a circle passes through the vertices of triangle ABC if the vertices are A, B and C having respective coordinates as minus 2, 5, B has the coordinates minus 2, minus 3, C has coordinates 2, minus 3. Then the center of the circle is out of these 4 options. So, very first let's consider here we have a triangle whose 3 vertices lie on the circle. Let's mark here the 3 vertices of the triangle. Here lies this point A having coordinates minus 2, 5. Here lies this point B having coordinates minus 2, minus 3, and here lies this point C having coordinates 2, minus 3. When you observe this point, here this is a line which is a vertical line having the equation x equal to minus 2. Here this is a horizontal line having the equation y equal to minus 3. When you have a horizontal and vertical line and they are intersecting at a point, then that means this point of intersection, at this point of intersection they will be perpendicular to each other. So, here this makes angle B equal to 90 degree. That shows us that this triangle ABC is a right angle triangle, and a right triangle always lies in a semicircle. This gives me AC as the hypotenuse of this circle, which is equal to the diameter of this circle. So, I could definitely state that hypotenuse will be equal to the diameter. So, for the solution, you can definitely write over here that triangle ABC is a right triangle. Therefore, midpoint of AC, that is the hypotenuse of the triangle, will be equal to center of circle. Will have the coordinates equal to center of circle. So, taking that into consideration, here I can easily get the midpoints if I consider center has the coordinates x, y, then here this will be equal to the midpoint of AC, and midpoint of AC will be average of x coordinates and average of y coordinate. So, I have here minus 2 plus 2 upon 2 as x coordinate and 5 plus minus 3 upon 2 as y coordinate. And when you simplify this, you get the respective xy coordinate of the center equal to 0, 1. So, I could write here that in this figure, the center of the circle will have the coordinates 0, 1. So, I hope this question is clear to you, where we have obtained the required answer as option number 2. And you can definitely mark your answer as option 2. Now, let's proceed to our next question.